Good afternoon. My name is Andrew Grimshaw. This is the next in the series of short tutorials on how to, in this case, install a GFFS container. This particular presentation is going to have a little bit more material up front while we explain exactly what you're about to do, and then the actual installation will not take very much time. The intended audience for this is system administrators or owners of resources who want to share those resources via the GFFS, whether these are compute or data resources, whether they're at centers, campuses, or research groups. We're going to assume that they have a properly installed they have properly installed a GFFS client in the past, and that they have an identity, and that they understand the basics of the GFFS.g GUI. Now, if they haven't actually got one installed on the machine, a GFFS client, that's okay, because we'll be reinstalling it in the course of doing this. So mostly we want you to have been through that process. We're also going to assume that you have a machine and adequate permissions on that machine. The details of the machine we're going to go into more in just a minute. By permissions, we mean you have permission to install software, and that you have the ability to make sure that the firewalls are open so that you can receive packets. At the end of the tutorial, you should be able to install a new container and link it into the grid as a grid resource that then can be used subject to access control. So the first steps, this first time we want you to be able to open the omnibus to D4. I always like to mention this to people because it's really important that you understand that there is documentation and where to get to it. So this is the section of the manual, and you'll be seeing some of these screens in just a moment. Similarly, you're going to need to download the appropriate installer. Now, the installers can also be found on the web page, and if we go back up here, we can see that there's downloads, and there's a set of installers for the XCG grid. For the GFFS.eu grid, there's a set of installers, and there's a set of installers for Exceed grids as well. So that's the next thing there that you need. And then you need to decide on this machine that I was talking about earlier. You need to know what local user ID you're going to run it as. You need to be able to log in as that local user ID. You need to know what grid user ID is going to own the container and what port number you want to run it on. The next step will be to actually run the installer and link in the new container that you create, and at that point you'll be done. So the important thing to keep in mind about the GFFS is that it's a system of systems. There's a lot of different instances of the GFFS that run, and then they all hook together in order to form the total system. Furthermore, not all of these implementations have to be by the same team. The particular one we're going to be showing you is the Genesis II GFFS container, but there's nothing that says that there won't be other containers, and particularly with respect to execution services, those can be provided by Unicore. So it's a system of systems. Different organizations may have different compliance stacks, and we're going to be showing you one of those. A typical campus setup has a number of different components. You may have campus clusters, researcher data sets, file systems, and they're all connected to the internet somehow. This is obviously a simplified diagram. We're going to be interested in one of those machines, which we're going to call the grid interface unit, and you may have more than one of these. And the grid interface unit is the unit that basically virtualizes the resources on your campus and makes them available to researchers and others outside of your campus. And it makes them available, of course, subject to access control and authorization decisions that you make. So any particular grid interface unit is going to need to be able to see the resources that it's virtualizing on your behalf. And we'll spend a little bit more time on this in a minute to say what exactly that means. So here we have a simple grid interface unit. Let's assume it's a single machine somewhere. And by the way, a grid interface unit can run on another server that you already have in existence. It doesn't need its own server. Depending on its usage, it will generate more or less load. It should have, as we'll see in a minute, at least 4 gigabytes of memory. So the grid interface unit is going to run a web services container. That's our container. And it needs to have some local disk that it can save information in a database. We found that running databases on network attached storage isn't particularly effective. So really would like there to be a local disk. The grid interface unit needs to be able to see the local queuing systems or load management systems that it's going to submit jobs to. If you're not planning on sharing compute resources, or more specifically compute resources managed by a local queuing system, well, then you don't need to be able to see one. Similarly, if you want to be able to share file system information for people, the grid interface unit needs to be able to see those file systems, whether they're on the local disk or whether they're on the distributed file system somewhere. So what are we going to install? We're going to be installing the Genesis II software stack, and it implements some campus bridging components, the GFFS. It has a metascheduler on it that you can choose to instantiate or not, and it has a BES implementation, basic execution services implementation, and you can choose to instantiate that or not. The installer software can install either a client, which some of you may have already done, and or the client and the container. The client software includes the GUI, the CLI, the GFFS fuse driver, things like that. And the container is a set of services in a web service container that implements the Exceed services. So why should you want to install a container? The basic idea is if you want to share resources within Exceed or within the GFFS.eu. So these could be compute resources like desktop machines or clusters, data resources such as files, directory trees, zip files, CIFS mount, whatever, identity resources and things like that. So a couple of things before starting a container on your home resource. You need to pick your GIU. This can be a Windows machine, a Linux machine, or Mac OS that can access the resources you want to share and virtualize. We'll be doing this on a Linux container machine in just a minute. You need to ensure that the machine has a public IP address. This is really important. You can run them behind NATs and firewalls. It's more complicated. We won't be talking about that here. You need to choose an open port number. We recommend you use the default port number of 18443, and if you do this, we will be able to talk to you. You need to ensure that you have sufficient storage on a locally attached disk. You need to have at least 5 gigabytes for a moderately sized resource if you're not planning on doing much with it. If you're going to be acting as a storage server, you need to have access to many more gigabytes of disk, potentially terabytes if you're going to be sharing a lot. In terms of memory, you really should have, these days we recommend at least 4 gigabytes of memory. The program itself can operate pretty effectively with 512 megabytes, but we found that if there's more memory on the machine, all the file system caches and everything work a lot better. I want to stress again that since we use an on-disk transactional database, that we really would like you to have an attached disk. If you're going to share a cluster or a supercomputer, the GUI must share a file system with the compute nodes. This is because when we stage data in, we're going to put it on this file system so the compute nodes can see it. And similarly, when we stage things out, we need to be able to see it so that we can stage it out. And this file system has to have sufficient space for the input and output files and temporary files used by the jobs. You need to choose a local account that will run the grid container. I want to stress that this does not need to have root privilege unless you're running on a Windows host, and that the only reason there is so we can install it as a service. If you're going to share local user directories, it's best if your file system supports extended access control lists and are turned on in your local environment. The reason for this is discussed when we talk about exports in another instructional video, but right now that's the case. And then finally, you need a grid account for the user or group that's going to own the container. So to download the installation bundle, you're going to go to, for example, here, the downloads page. You're going to select one of these to download, and we're going to be using the 64-bit installer. The container installation, just so you know, is going to create a process that's running a web service container on your machine that will turn on HTTPS and SSL communication and will listen on a socket and communicate using HTTPS. It will deploy and configure some certificates and trust stores, which are described in the documentation, that allow the grid containers within one grid system to authenticate and or trust others. It's going to download information about the global namespace root and store it in a local state directory. It's going to execute some code to generate a new grid certificate container to be used for SSL traffic with other containers and clients, we can either generate one for you automatically, or in fact you can choose to use your own certificate if you have that. If you're going to use your own host certificate, we recommend an IGTF certificate, or one from the IGTF, International Grid Trust Group, approved certificates from the CA, for example, from Certificate Authority from Exceed, or one of the European certificate authorities in the IGTF. Then once that's all started up, we'll register this in the global namespace, and we'll show you where you can put that. So that's that. Let's get on with it. We'll close this out. We'll close that out. This is the Linux machine that I referred to. This is a machine in Virginia. I happen to be right now in Germany, so some of the X Windows operations will be a little bit slow. I just a moment ago downloaded the installer, version 2753, onto the machine, and what I need to do as a first step is I need to chmod that so that I can execute the script. So I run chmod, and then I run the script. You can also use RPMs. I'm personally not an RPM person. I prefer using the installer, so that's what I'm going to use. So it unpacks like most installers. It's going to start the installer up. Right now what it's doing is communicating to my X Windows environment to set up the X window. And now is when you can really tell that I happen to be in Germany. Okay, so it's come up, and it's the installation wizard. This one is for the cross-campus grid, and basically what I'm going to do is hit next all the way through this. So it says, where do you want to install it? Well, it tells me where it will by default, and I'm going to accept the default. How much disk space that needs, how much is there. I'm going to click next. It asks me, do I want to install just the client or the client and the container? And so I want to select client and container, and I hit next. So it's going to extract these files from the installer and set them up. It's then going to ask me what port number I want to use, and I'm going to use port number 18443, and then I need to specify the host name. Now this needs to be a resolvable host name, and in fact I forgot what the host name is on this machine, so I'm going to type host name, and it's uvax-001. I'm going to put that back in the foreground, and it's uvace-001.cs. Oh, it was on top of my screen there. I could have just done that. .virginia.edu, and let that go. Now, one of the things that you might want to do if you anticipate wanting to move this to another machine later is create a new DNS name. So for example, I might create a local DNS name called Virginia GFFS server .cs.virginia.edu, and then alias my host as that. That way later, if I want to move it to another machine, I can easily move it, redo the DNS entry to point to the new host, and I'll be fine. But this is just a temporary container for this tutorial, so I'm going to just put it on this machine. I hit next. What it's doing now is it's connecting to the mothership, so to speak, in order to get the right address of the root of the namespace, and then ask me for my username in the grid, and I'm going to use my username, which is Andrew, which I hope I've typed in correctly. I hit next. This is the person who's going to own this container, in terms of they will have the permission to use the container and manage the container. So I'm going to use the key compare generating service. This is generating that SSL key that I spoke about a few minutes ago. Then it's going to ask me what I want the password to be for the Keystore. The default is container. It's not very exciting. I would strongly recommend that you put something else in there, and then you hit next. Okay, so now we're done. The only question is whether we want to start the container service automatically. I'm not going to do that because I want to be able to show you how you start the container service. Now in Windows, the Windows prompt will ask you whether you want to start the service there. I would say yes, because in that case it's going to do all the work to install it, put it in the registry as a service, and get it running, which is why you need to have admin permissions on a Windows machine. In Unix, as you'll see in a minute, there's a program that you run that you'll want to put in your init scripts for the machine if you want it to be restarted regularly. So I'm going to say finish, and then it's going to do the rest of the install. It's now done. I say finish, it's done, and what we'll see is all of that stuff is now there. So if I want to actually start the container, at this point there's no container running on this machine. If I do a ps-x, you'll see that there's nothing running there except my shell processes. So now what I'm going to do is I'm going to go down into Genesis, and now we'll see a number of things. And the most important one of these is, well, first there's the grid command, which is what we use to talk to the grid. This is the client program that we saw earlier. So I'm going to run the grid command and just show you. I'm going to do an ls. And since I'm not authenticated, it's just going to show me the root of the namespace. I'm going to quit that. Then what I'm going to do is start the container up on this machine. Before I do that, I want to point out one other thing that's important in this directory. You'll see a file called serviceurl.txt. It's right here. And if we cat that file, it will give us the name of the service and the port that it's at and a few other little things. And this is essentially the entry point to this container, the first time that somebody wants to talk to it. And this is the thing that we're going to need to link into the grid so that other grid resources know about this resource. So to start up the container, what we do is we type .gffs container, and this is a shell script. And I'm just going to hit carriage return. It will give us the usage where we can basically say I want to start it in the console, I want to start it, I want to stop it, I want to restart it, or I want to check the status or dump. We're just going to do a start here, and the container will be up and going. It's up. And now if we do a ps-x, you'll see that we have a wrapper, and we also have a copy of Java running. The wrapper is a program that if the container fails, it will automatically restart it. The container itself is now up and running. The wrapper, of course, won't restart it if the machine crashes and restarts. In order to do that in Unix, you would need to put it in an init file or an RC file, depending on what you're doing on your particular machine. Okay, now that the container is up and running, what we need to do is go into the grid shell, log in, and link it into the global namespace. Nothing could be simpler. So the first thing we're going to do is we're going to go into the grid shell. It's going to pop up. We're going to see that, in fact, I'm not logged in as anybody. Do a who am I, and it'll say nobody's there. So now I need to do a login as myself. And now I need to type in my password. I've previously put that into my copy buffer. I'm going to Control V that into there, and then I'm going to say OK. And at this point, what's going to happen is we're logged in. And if I do a who am I now, it will show who I am. So I'm going to go into my home directory. And when I do an ls, we're going to see a bunch of things in my home directory. And I'm going to scroll back up. Oops, I'm not in my home directory. I must have made a typo somewhere. Yes, I need to cd into my home directory, not just into the overall directory. Now if I do an ls, we'll see a number of things in my directory, and one of them is this directory called AGDT. Well, that happens to be a container that's running on my desktop back in Virginia. And in fact, if I look down inside of AGDT, what I will see is some files. The first one is a directory of the resources that are on there. The second one is a text file that has what the free space is on the disk for that machine. The services directory says what services are operating on the container, and then there's a log file that I can look at later if I want. So what we want to do is link in this new container we created in much the same way as I previously had linked in the AGDT. So I'm going to scroll back up here till we get to this service URL, and I'm going to copy that into my copy buffer. And now what we're going to do is we're going to link this into the grid in much the same manner. If we do a help on link, it will tell us some of our options. We're going to be using the -- service URL option. So I'm going to say link -- service. Oops, need to learn to type. Should have found the key first. Service URL equals, and now I'm going to paste that in, and I'm going to call this the UVAX container, or we'll just call it VAX container. Why not? We'll go backward in time here to the days of Vaxxin, and that's going to go out and create the link. And now when I do an ls, there'll be a new entry called VAX container. You can see it down here. And I'm going to do an ls on VAX container. And we're going to see exactly the same things that we saw earlier: the resources, the file system summary, etc. So this container is now in. We can do things with this container. We can create exports, and there's a video on that. We could create a new BES, basic execution service, and there's a video on how to do that. All these things are also described in the documentation. That's the end of this particular tutorial. We hope that you found it useful, and goodbye.